In this lesson, we're going to learn how to solve some rational equations. Now, a rational equation means you're going to have several rational expressions, either being added or subtracted, and then an equal to and another rational expression on the other side. What's going to be crucial to solve these equations is the use of the LCD. As you know, in an equation, when you multiply through by the LCD, no fractions remain. So for our first example, we're going to take 1 over 8 plus 1 over x equaling 1 over 6. Now we're going to figure out what our LCD is. For the 6 and for the 8, what are we going to use? Well, for 6 and the 8, out of both those will divide out of 24. Then, of course, we also need the x. So we're going to multiply 1, 2, 3 times by a 24x once. There it is twice, and a third time. Now, 24 over 8 will go 3 times, so there's the 3x. The x's cancel in the second one. There's the 24. And 24 over 6 will go 4 times, so there's the 4x. Now we're going to bring the 3x to the other side by subtracting, and we're going to have x equaling 24. Now, we have to look, and we see that our denominator had an x in it. So we're going to have to make sure, since that x is right there, that no solution, and we knew from the beginning a solution couldn't be 0 because we can't have 0 in a denominator. We have to watch out for extraneous solutions for these things, so 24 checks out okay when you plug it back in. So always be checking your answers to make sure you're not ending up with an extraneous solution in this type of problem. Alright, now for our next problem, we're going to look at 1 over x equaling 1 over 2x plus 1/2. Again, for an LCD, we're going to look, and this time it's a 2x. Now, we're multiplying by 2x 1, 2, and 3 times. In the first one, the x's cancel and we get a 2 equaling. In the next one, the entire 2x cancels and we've got a 1 plus, and the 2 cancels, leaving with us an x. And that means x equals 1 when we subtract. And again, noticing that we had x's in the denominator, we knew from the beginning x couldn't be 0, so 1 should be an acceptable solution. Okay, let's move on. Now that we know that the 1 works and it's not extraneous, we're going to have 1 over x minus 2 minus 4 equaling 3 minus x over x minus 2 again. Now the LCD is going to be the x minus 2 because that's the only denominator we have. So we're going to multiply by x minus 2 once, and again, and watch your grouping symbols, and again. In the first fraction it cancels, you're left with a 1. In the next fraction, I'm going to have to distribute carefully. It'll be a minus 4x plus 8 equaling, last fraction, cancellation, you got a 3 minus x. So, let's combine like terms. 8 and 1 is 9. And then I'm going to add the x to bring it to the left. Negative 3x plus 9 equaling 3. And then subtract the 9. Negative 3x equals negative 6. When I divide by negative 3, I get that x equals 2. But don't forget, since our denominator had an x minus 2 in it, and since x minus 2 can't be 0, x can't be 2. Therefore, the 2 we found for a solution is in fact extraneous, and that won't actually work when you plug it back in. So, we need to say there's no solution. Now, you can do this a couple ways. You can say empty set brackets or no solution set symbol. Either way, you got to make that clear that you know that there is no solution. Alright, so let's look at our next example. And that's going to be a 1 over x plus 1 plus 1 over x minus 1 equaling 5 over 12. So, we're going to look around and see that our last few problems were linear. I believe that's going to be different this time, though, because with linears, you can solve for the x outright. With this one, if it turns into a quadratic, we won't be able to do that. So our LCD is going to be the x plus 1, the x minus 1, and I think I need to make a little bit of room over here. Didn't save space, but we're also going to have a 12. So that's our LCD. I'm going to have a 12 times an x plus 1 times an x minus 1 over an x plus 1 in the first fraction, plus a 12 over an x plus 1, x minus 1 over x minus 1 in the second fraction, equaling 5 times the 12 times the x plus 1 times the x minus 1 over the 12 in the last fraction. So I've multiplied 1, 2, 3 times by the least common denominator. Let's start canceling. Here you cancel and you're left with a 12 and an x minus 1. Plus, here you cancel and you're left with a 12 and an x plus 1. Over here you cancel and you're left with the 5 and the x plus 1 and the x minus 1. Now here I can distribute pretty easily. 12x minus 12 plus 12x plus 12. Over here it's a 5 and an x squared minus 1. Combining, 12's cancel, you get a 24x equaling a 5x squared minus 5. Now here's something that's really different. Linear equation, linear equation, linear equation. Now we've got quadratic. Linear equations you can solve outright. With the quadratics, I got to bring the 24x over, set it all equal to 0. And if this thing's going to have solutions, I'm going to have to find them by factoring. So let's see. Looks like we're going to have, let's see, for the 5x squared, we'll try a 5x and an x. And for this 5, we'll try a 5 and a 1. Let's see how this works. If I have a minus and a plus, I'll have a negative 25 for the outer product, a positive 1 for the inner product. That'll give me a negative 24. That factors. So I have a 5x plus 1 equaling 0, and an x minus 5 equaling 0. So x will be a negative 1/5 and a positive 5. And of course, from these original denominators, we know that x can't be 1 and x can't be negative 1. So I do believe those answers are perfectly legitimate. So remember, solving rational equations is all about multiplying through by the LCD and solving either the linear or the quadratic equation that results.